Good. All right, so next we need to get the derivative of the cosine. So let's go ahead and work on that. So if f of x equals the cosine of x, find f prime of x. Let's go through it again. F prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay, so this will be the limit as delta x approaches 0 of the cosine of x plus delta x minus the cosine of x all over delta x. So we need to evaluate this limit. And this one's going to kind of be, evaluating is going to look kind of similar to the sine one because we have this cosine of x plus delta x and we need to expand that out using a cosine sum formula. So let's see if we can remember that. The cosine of a plus b equals the cosine of a, cosine of b, minus the sine of a times the sine of b. That means the cosine of x plus delta x is going to be the cosine of x, cosine of delta x, minus the sine of x, sine of delta x. So let's take this cosine of x plus delta x and substitute it in to the cosine of x plus delta x in our limit. So we're going to end up with the limit as delta x approaches 0 of the cosine of x, cosine of delta x, minus the sine of x, sine of delta x. And we're going to subtract out a cosine of x, and then this is all going to be over delta x. So we want to evaluate this limit now. So we expanded out the cosine of x plus delta x. Alright, again we're going to do a little rearranging. I'm going to take this negative cosine of x and put it over here. Use the commutative property. We have the limit as delta x approaches 0 of the cosine of x, cosine of delta x, minus the cosine of x, minus the sine of x, times the sine of delta x, all over delta x. Then we're going to take this fraction and split it into two fractions. The first fraction will be the cosine of x, cosine of delta x, minus the cosine of x, all over delta x. And the second fraction is going to be a negative sine of x, sine of delta x, all over delta x. And then in one step we'll also go ahead and split those into two separate limits. So we're going to end up with the limit as delta x approaches 0 of the cosine of x, cosine of delta x, minus the cosine of x all over delta x, minus the limit as delta x approaches 0 of the sine of x times the sine of delta x all over delta x. Okay, so this one is looking very similar to the derivation of the sine. Kind of doing the same steps, it's just the result will be slightly different. Okay, so here we're going to factor out a cosine of x. So this is going to be the limit as delta x approaches 0 of the cosine of x times the cosine of delta x minus 1 all over delta x. And then we're going to subtract the limit as delta x approaches 0. And we'll do the same thing here. We're going to factor out a sine. So we're going to have the sine of x times the sine of delta x all over delta x. It sure is raining a lot outside right now. Anyways, the next thing we're going to do is we're going to take this product inside the limit and make it the product of two limits. Same thing over here. So we're going to end up with the limit as delta x approaches 0 of the cosine of x. And then we're going to multiply that by the limit as delta x approaches 0 of the cosine of delta x minus 1 all over delta x. Then we're going to subtract from that the limit as delta x approaches 0 of the sine of x. And then we're going to multiply that by the limit as delta x approaches 0 of the sine of delta x all over delta x. Good. Okay, so some good things start happening right now. When we substitute in 0 for delta x for this one, well, there's no delta x, so it's just the cosine of x. Now this one here we can't substitute in 0 because it becomes undefined. However, just like in the previous example, we've shown that this limit equals 0. Here, we substitute in 0 for delta x and it becomes just the sine of x. And then you can't substitute in 0, but we do have that special limit that says that the limit as delta x approaches 0, the sine of delta x over delta x equals 1. So after we go all through this, we end up with, let's see here, the cosine of x times 0 minus the sine of x times 1. And this all equals a negative sine of x. So here is our cosine rule. And the cosine rule states that if f of x equals the sine of x, f prime of x equals, that's wrong. Let's rewrite all this. If f of x equals the cosine of x, then f prime of x equals a negative sine of x. Sorry about that. Okay, so let's look at these two side by side. I can do that again. And I'll fit it in here. So let's say we have y equals the cosine of x. So we go from 1 to negative 1. And the cosine starts off at 1, goes down, and comes up. There we go. Now we're going to look at y prime equals a negative sine of x. Okay, now remember, negative sine of x is the sine function, however it's going upside down. So let me see here if I can. So that's 1, that's negative 1. So here will be a so it'll look something like this. There we go, negative sine of x. So when the cosine starts out, it's actually at a maximum. And when you have a maximum, you have a horizontal tangent line, so the derivative, or the slope of that tangent line is 0. and the cosine starts off going in a negative direction. Okay. When we get here, we have a slope of a -1. The tangent line has a slope of -1. And then it's still negative until it gets to a point where it's, again, a minimum, or we have a horizontal tangent and it has a slope of 0. Then the slopes start increasing until we get here where we have a slope of 1, tangent line, and then it keeps on increasing until we get back to a horizontal tangent. And so there is kind of a graphical look at what's happening between the cosine and its derivative, negative cosine. Alright, so let's take look at a couple of examples. So in this example, if we have y equals 3 times the sine of x, and if you want to find y prime, well, we're only multiplying the sine of x by a 3, so we just leave the 3 in front, and the derivative of the sine is the cosine. So this becomes 3 times the cosine of x. That's not too bad. If we have, for this example, let's say we have y equals x plus the cosine of x. And we want to take the derivative of that, so we still first have to take the derivative of x. The derivative of x is just 1. And then the derivative of the cosine is a negative sine of x. And that is easy enough. Okay, so there are our rules for sine and cosine. Remember, the sine rule is that the derivative of the sine is the cosine, and the cosine rule is the derivative of the cosine is a negative sine. Do remember to keep track of which one has a negative, but that's not too bad. The cosine is a negative sine.